Hi, my name is Hope Lee, and this is my video for Lab Report 4. In this lab, we focus on calculating the changes of energy in an oscillating system. The purpose of the lab was to observe the motion of a mass attached to a spring and compare it to a predicted model after calculating the kinetic, gravitational potential, and spring energy. A brief preview of the results showed that the observed motion and the predicted motion were similar in both axes, with the x-axis having the most similarities. There were also a few assumptions because the video was taken from a previous lecture. There were a few fundamental principles needed to tackle the lab. In fact, the whole lab is based around Newton's second law and changes of energy. In the lab, Newton's second law is used and it revolves around net force equaling a change of momentum over a change in time. Newton's second law can also be manipulated and rewritten into the velocity update formula as well as the position update formula. And the total net force of this experiment is found when the gravity and spring force of the object is added. Energy principle is also one of the fundamental principles used. It is used to find the energy of the system. In the system, Q was actually 0, and there are multiple forms of energy utilized in the experiment, including gravitational energy, potential energy, spring force energy, and the total energy conserved. On to the tracker data. For the tracker data, the origin was at the fixed point. The coordinate system was placed at the origin to have the initial velocity at 0, and the space was calibrated at 7 meters as seen in the video lecture. The waves in the tracker data actually depict the mass oscillation movement. On to the initial conditions. The initial conditions included the object's mass, which was given in the video lecture, the initial velocity, and the initial position. Time was 0, and we also found K in the relaxed spring length. The system was the mass, spring, and the earth, basically everything, and there were no surroundings. On to the coding iteration. In the code, it shows that the initial energies were set equal to their original values, and the gravitation and spring force were then calculated. Net force was found when the gravitation and spring force were added together, and those rewritten formulas for Newton's second law, the velocity update and position update formulas were then used to track the object, and the stretch of the spring was also found with a new position of mass by updating the value of L, L hat, and S. Lastly, a change in energy was calculated within the system using those energy formulas shown below. On to the comparisons. First, we'll start with the energy graph, the change in energy versus time. As you can see, spring, gravitational energy, kinetic energy were all present on the graph. They were all added together, and they had a constant change in energy where delta E is constant. And that makes sense because there's no work on the system from the surroundings, and that means the energy is constant. Since the model predicts the same, that the energy is constant, the energy principle is satisfied. Now on to the X position graph and the Y position graph. Both graphs are similar with similar peaks. The X position actually predicts higher peaks and ranges of values, but I think that is because there is actually air resistance in the model, reducing the range of motion. The Y direction graph also implies that air resistance is acting on the system because it is slowing down the mass, as showcased with the lower peaks for the experiment. Possible errors include that there could be a need to account for air resistance, and there could be an issue with the mass distribution of the system. And in all, this means that the Y period is shorter than the X period because of air resistance having a stronger range of the spring. Thank you.